today we're going to be factoring by grouping and factor completely. Remember, when you see the term factor completely, that usually means that there's more than one factoring step involved. So we're going to have to, in this case, factor by grouping and then look to see if we're done or not. Okay, factor by grouping. Some of us factor trinomials this way, but basically when there's 4 terms, the first thing that you always need to check is see if there's a greatest common factor. Now, typically when there's 4 terms, there's no greatest common factor because the first term just has letters, the last term just has numbers, so that means that all 4 of these terms do not have something in common. Your second step is then to factor by grouping. Factor by grouping means that right after the second term, you're going to split this into 2 groups. In the first group, we're going to see if there's a greatest common factor. What do the first 2 terms have in common? What could we divide out of both of those first 2 terms?
Z squared.
Z squared. And when we divide by z squared, or factor z squared out, z cubed, if we take z squared out, we'll be left with z. 5z squared, if we take the z squared out, we're left with 5. Then we go to the second group. A really helpful hint, whatever symbol is in front of the third term, drop that symbol down. What do negative 4z and negative 20 have in common? Negative 4. You can divide both of those things by negative 4. And just in case you don't realize that it's negative 4, dropping that symbol down will help you to know that it must be negative 4. All right, negative 4z divided by negative 4 is z. Negative 20 divided by negative 4 is positive 5. Do you see how the z plus 5 is the same on both of those? It must be the same in order for this factor by grouping to work. The next step is to collapse this down. The z squared and the minus 4 is your first set of parentheses. The z plus 5 is your second set of parentheses. Okay, the common question I get with factor by grouping is, where did the other z plus 5 go? If I were to take this bottom line that we have right now and tell you, multiply this out, you would take z squared and distribute it to the z and the 5. That's what's written right here. Then you would take negative 4 and distribute that. That's what's written right here. So that middle line is the distributive property fully written out, and we're just collapsing that down into 2 binomials. Take those out. Okay, so this is our factored form, but because it says factor completely, we have to think about, are we done or not? Your final step is going to be look for x squared minus. If you see x squared minus, you're probably not done. X squared minus, or in this case z squared minus, means that there might be a difference of 2 squares hiding there. So z squared minus, z squared is the perfect square of z, 4 is the perfect square of 2. So that part factors into z plus 2, z minus 2, and we have the z plus 5 from above. That is fully factored. Okay, let's do one more together, and then I'll have you try one on your own. In example B, the 4 terms do not have anything in common because the first term doesn't have a coefficient and the last term doesn't have a variable. So we're going to split this after the second term. What do x cubed and negative 2x squared have in common? X squared. X cubed, take x squared out, we've got x left over. Negative 2x squared, take the x squared out, we're left with negative 2. What do 9x and 18 have in common? 9, and it needs to be negative 9. Negative 9x divided by negative 9 is positive x. If we had done a positive 9, we would have ended up with a negative x in the parentheses, and that's no good. 18 divided by negative 9 is negative 2. If we had done positive 9, that would have been a plus 2. Our parentheses would not have matched, and that would not have been good. So our factored form is x squared minus 9 times x minus 2. Are we done? X squared minus, we're not done. What is 9 the perfect square of? 3, so that factors into x plus 3, x minus 3, and we have the x minus 2. Okay, why don't you try, C's got kind of a weird thing in there, but why don't you try C on your own? Be brave. Pause the video, try C on your own. A couple things that people struggle with in example C is the second group appears to have nothing in common, but they always have at least a 1 in common. So they have a negative 1 in common. So we have x squared minus 1, x plus 4. The next thing people struggle with is a lot of people don't realize that 1 is a perfect square. 1 is the perfect square of 1. So this factors into x plus 1, x minus 1, x plus 4. That is the fully factored form. In example D, first of all, I notice that there's a number in front, which makes me think, oh, maybe there's a greatest common factor. Maybe there's something that these 4 terms have in common. But as we look through, no, there's definitely not. So we split this. These two have y squared. 3y plus, what do I put here? What's y squared divided by y squared? 1. You have to put that 1 there as a placeholder, so that if we actually took the time to multiply this back out, we would end up with 3y cubed plus y squared. 9y and 3 have 3 in common. 3 divided by 3 is 1. So our factored form is y squared plus 3, 3y plus 1. Now we're used to doing another step after this, but this is y squared plus. Y squared plus, we can't factor that anymore. It is done. Okay, remember your perfect squares. I'm going to pause the video and fill this in. If you're watching this video, I would pause the video and get those recorded. Add 16 and 25 in there because 256 and 625 are definitely numbers that we are going to see popping up. Okay, we've been using this difference of two squares pattern, where if you have a perfect square minus a perfect square, it factors into the square root plus the square root minus. We're going to do that again with larger exponents. So I told you that if you see x squared minus, you're likely not done because it's likely a difference of two squares. If that exponent is an even number, if you have x raised to an even number minus one other term, there's a chance it's difference of two squares. So 16x to the fourth minus 81. 16 and 81 are definitely numbers on this chart. So 16 is the perfect square of 4. X to the fourth is the perfect square of x squared. X squared times x squared is x to the fourth. So basically you take that exponent and cut it in half. 81 is the perfect square of 9. So this is 4x squared plus 9. 4x squared minus 9. Are we done? Do you see x squared minus? X squared minus means we might not be done. 4x squared is the perfect square of 2x. 9 is the perfect square of 3. So that part factors further into 2x plus 3, 2x minus 3. If it's only two terms with x squared plus, you are done. It's only x to an even number minus that you have to worry about. So we got b factored, but now some of you are looking at this and saying, wait a minute, I see x squared minus and 4 is a perfect square. Could we factor this chunk more? But because that's a 5 in front, is 5 on that perfect square list? No. So then it is not possible to factor it anymore, and that is done. Example C, it doesn't look like the difference of two squares because it's n to the 4th plus, but do you see how there's a negative in front? We don't like a negative in front. So our first step is factor out a negative. Okay, now pause the video, and on your own, I want you to try factoring 16n to the 4th minus 625. As you factor this, just don't forget that you've got that -1 that we factored out originally, so your final answer, your final factored form should have a -1 in front of your answer. We started by taking out a greatest common factor, and now what we're left with is x to the 4th plus 5x squared plus 6. This is very, very similar to x squared plus 5x plus 6, except it's x squared in the middle instead of x, and it's x to the 4th in the front instead of x squared. But we're going to treat it exactly the same way. We're going to look for two numbers that multiply to give us 6. Those same numbers need to add up to 5. That would be 2 and 3. Normally, we would do x plus 2, x plus 3. But if I multiplied this out, x times x would give me x squared. I need it to give me x to the 4th. So we just put a square on both of those, and that fixes it. X squared times x squared is x to the 4th. Basically, whatever the exponent on your middle term is, that's the exponent that you're going to use in your factored form. We still have the 3x squared in front. I don't see any x squared minus, so we are done. Okay, let's try that with E. First of all, we need to see if there's any greatest common factors. I believe there is. We can factor 2 out of everything. And how many x's? X to the 5th. Take your smallest exponent on your x's. When we factor trinomials, we're looking for two numbers that multiply to give us the last term 4. Those same numbers need to add up to the middle term 5. I believe that would be 1 and 4. But we can't just do x plus 1 and x plus 4, because x times x is x squared. We need the x times the x to give us x to the 8th. Whatever the exponent is on your middle term, that's the exponent that you want to use in your factored form. So x to the 4th plus 1, x to the 4th plus 4. X to the 4th times x to the 4th gives us x to the 8th. Once you have it factored like this, check to see if there's any more factoring you could do. I don't believe there is on this one, so we are done.